Hello radiographers, I hope you are doing good. So today I am going to discuss you with some parameters in Siemens MRI. So for this I have to open a protocol. So suppose I am opening T1 team cells from brain, and in the protocol section there are the parameters of this protocol. So if you see down that there are some options like routine, contrast, resolution and geometry, system, physio, inline, sequence. So these are the options in which the parameters lies for this protocol. So generally the engineers or applicationists set their default protocols here, and these are the standard protocols. So if you want, you can change the parameters, but I will suggest you not to do this. Then if you do this without knowing, then you will change the contrast or resolution of the protocol. So let's introduce the parameters here in routine section, and I will discuss one by one later. So first, in the routine section you can see the above, there is a line. So in this line there are some text. So let's introduce them. The first one is the TA. So TA means acquisition time. That means the acquisition time of this scan is 1 minute 43 seconds. And then the PM. So PM means the positioning mode. So there is 3 types of positioning mode in Siemens. One is fixed stable position. You can see that when I move the cursor to the fix, it appears fixed stable position, and then ref is linked to reference image and the ISO center. So I will discuss later about this positioning modes. And then the PET. So PET comes from the parallel imaging technique. So there are some techniques that in software that machines can take parallel imaging technique in different methods. So one of the method of parallel imaging technique is GRAPPA in Siemens, and there is another methods I will discuss later. And then the voxel size. So we know that every pixel has volume. That means that the pixel has a height, a width and a width or length. So this is 0.9 and 0.9 and 5 millimeter. So 5 millimeter is the thickness. You can see that the slice thickness is 5. So this is the 5 millimeter thickness here, and this is the height of the voxel. And 0.9 and 0.9 is the length and width of the voxel. So we know that our display monitor is comprised of thousands and millions of pixels, and each pixel has a voxel or volume. And then the real SNR, and that is the relative SNR. So SNR means the signal to noise ratio. So, and this is 1, and this is a constant number. So if you change some parameters, the SNR will decrease or increase, and this represent that your image is going to high resolution or going to low resolution. If you change some parameters here, the SNR will change, and it will tell you that by changing the parameters you are changing the resolution higher or lower. and then another TIR, and that means that this is the type of the sequence. This means that TIR means the turbo inversion recovery sequence. So this is the slice group. The slice group is the number of group of the slice. Like you in the lumbar spine axial planning, we group the slices, 3 slices in one group. We place 3 slices in a intervertebral disc, that is a group, and then the slice number. So we can give 3 slices in a group or 19 slices a group. So like in the brain, we give 19 slices for sagittal. So this is a one group of slice. And then the distance factor. Distance factor represents the gap between the slices. And if you increase the percentage of the distance factor, the gap will increase. And if you decrease the percentage of the distance factor, the gap between the slices will decrease. And this is the position of the planning from the ISO center of the machine. And this is the orientation. Orientation means that how you want to plan the slices, sagittal, coronal, or axial, or oblique. This is the phase encoding direction, and AP means the anterior posterior. So how the phase encoding gradient will collect the signal in which direction? It can be changed to head to foot or AP, anterior to posterior. And this is auto align. There are options in Siemens to auto align the plan. Suppose in head brain, after the localizer, auto align localizer, the other protocols will be planned automatically in the proper region. You don't need to plan manually if you use auto align and select auto align in all the protocols. Phase oversampling is an important factor. Phase oversampling increases the field of view, and it's very important to overcome the artifact like wraparound artifact and phase oversampling artifact or aliasing